Death is the final frontier. Our brains were made for the service of survival, to prevent the inevitable for as long as possible. From the moment of our birth, our brains are wired with a basic set of instructions, fundamentally set for survival. Over time, this core code is modified, changed, and edited based on our experiences and our environment. The brain becomes extremely proficient and efficient, a lean, mean learning machine made to keep you alive. It is the fundamental stones on our being, ingrained deeply within the fabric of our biology, genetics, and psychology. Our cognitive processes, emotional responses, and instinctual reactions are all honed toward the singular goal of prolonging life and ensuring our continued existence. This drive for survival is expressed in many ways throughout our lives, seeking food and shelter, avoiding physical harm, forming social connections, and striving for success and achievement. Our brains are constantly assessing risks and rewards, making decisions, and adapting our behaviors to maximize our chances of survival and reproduction. Despite its best efforts, though, death remains an inevitable and an inescapable reality. That is, in a nutshell, the human condition. Our drive for survival compels us to seek meaning, purpose, and fulfillment in the time that we have, to leave a lasting legacy, to find solace in the knowledge that our lives, however fleeting, are part of a larger tapestry of existence. Welcome to the Sum of All Fears, our final session in our exploration of fear. I'm Brian Beach, and we have a lot to cover, so let's get started. In this module, we will do a quick review of what we've discovered so far, identifying key points from each of these sessions so that we can tie all these ideas together. Then that will lead us into an extended series of discussions related to everything that we've learned. We'll then make our final conclusions and offer suggestions for books or videos if you want to explore this topic and learn more. In the first module, we discovered fear has captivated the human imagination since antiquity, prompting philosophical inquiry and shaping our understanding of the human psyche. Ancient philosophers such as Plato and Aristotle contemplated the nature of fear, viewing it as a fundamental aspect of the human existence linked to survival instincts and moral virtue. Throughout history, scholars and thinkers have grappled with fear's complexities, its role in religious and mythological narratives, to its implications for individual and society well-being. In the historical understanding of fear include philosopher René Descartes, who proposed a dualistic view of mind and body, and posited that fear arises from instinctual responses rooted in the body. Centuries later, Ivan Pavlov's work on classical conditioning laid the foundations for understanding how fear response could be learned and conditioned, setting the stage for further research in behavioral psychology. The traumatic experiences of World War I and the emergence of shell shock brought the study of fear into sharp focus. Researchers like Walter Cannon investigated the physiological mechanisms of fear. Cannon's concept of the fight or flight response highlighted the body's adaptive physiological reactions to perceived threats, shaping our understanding of fear's role in response to stress. John Watson's infamous Little Albert experiment demonstrated the principles of classical conditioning in the development of fear responses, illustrating how fears could be acquired through associative learning processes. Henry Clover and Paul Busey's crude dissection methods led to the discovery of the amygdala's role in fear response, further advancing our understanding of the neural circuits involved in fear processing. highlighting the amygdala's central role in detecting and responding to threat signals. Paul MacLean proposed the Truan brain theory, which conceptualized the brain as consisting of 3 evolutionary layers, including the reptilian brain, which is associated with instinctual behaviors like fear responses. This concept became part of our language, part of our lexicon, when Carl Sagan used the reptilian brain model in his popular science novels. Now, more recently, researchers like Jake Panskeep, Antonio Damasio, and Joseph Ledoux has expanded our knowledge of fear's neurobiological underpinnings, unveiling the complex interplay between brain regions and neurotransmitter systems that are involved in processing fear. And they've been doing this through incorporating new non-invasive technologies by being able to scan and monitor living brains. The historical events and achievements have shaped contemporary knowledge in psychology, neuroscience, and related fields, as well as popular culture and society's basic understanding of what emotions, the brain, and specifically fear are. Insights from ancient philosophy, classical conditioning experiments, and neurobiological research continue to inform modern theories and approaches to understanding fear, highlighting the enduring significance of fear in the human experience. Understanding fear requires a multidisciplinary exploration of its theoretical frameworks, origins, and contemporary research. The Nature of Fear module delves into the complexities of fear, encompassing the nature versus nurture debate, various models and discoveries, and cutting-edge research into fear. Theoretical frameworks, or models, evolve over time and provide valuable insights into the intricate workings of fear in our minds and bodies. The web of fear is such a concept that emphasizes the interconnectedness of fear stimuli and responses. It's such a model. Building upon the traditional fight or flight response, the term acute stress response has emerged to encompass the complex array of physiological, neurological, and psychological reactions to stimuli. The nature versus nurture debate offers perspectives on the origins of fear, with research indicating that our fear response system is a combination of genetic predispositions and environmental influences. Studies on specific phobias using twins suggest a heritable component, underscoring the interplay between genetic factors and learned experiences in shaping fear responses. Evolutionary psychology provides insights into the adaptive nature of fear, tracing its origins to ancestral threats and localized survival imperatives. Unlike our innate fears, specific fears, like those linked to spiders or snakes, are believed to reflect predispositions shaped by millennia of our human development, passed down genetically within specific groups, and are not universally shared. Contemporary research on fear mechanisms and responses continues to advance our understanding of this complex emotion. Experiments like the visual cliff illustrate the role of perpetual cues in fear conditioning, while studies on the patient SM shed lights on the neurological underpinnings of fear, revealing the critical role that the amygdala plays in fear processing. Patient SM, who has a rare genetic disorder resulting in an underdeveloped amygdala, serves as a unique case study in understanding the neural basis of fear. Her experiences highlight the pivotal role of the amygdala in external fear recognition, emotional processing, and social behavior, as well as indicate that other brain regions are responsible for internal threat awareness. This module attempts a comprehensive investigation into the complexities of fear, offering insights that inform both theoretical concepts and practical applications in psychology, neuroscience, and the treatment for disorders.